We come to our first speaker of this session, Yevheniya Nosyk from Course Labs, going to talk about ADoX deployment in the wild. And she promised not to dox anybody here, except the title.
It says I have 3 minutes left. Sorry? Okay, that's good. Okay. Do you hear me? Yes. Good afternoon, everybody. My name is Yevheniya, and I'll be talking today about my research on ADoX deployment in the wild. So, as you may have heard, there's been quite some community outreach in the past year regarding ADoX deployment, which included a couple of meetups like the ITF side meeting, a BOFA tribe, a discussion here at org. But what I'm presenting here is deployment data that shows where things stand right now. So when I say ADoX, I'm referring to this RFC 9539, which was published 2 years ago. So this is an experimental RFC that came out of the DPRIVE working group at the ITF, which is as of now closed. So there are two important keywords in the title, unilateral and opportunistic. So unilateral in this context means that resolvers can establish encrypted connections with name servers without any prior coordination. The opportunistic security means that we try to encrypt something that would otherwise be sent in clear text. So both DOT and DOQ can be used opportunistically, as long as they run on the default port 853, but we cannot use DOH opportunistically yet. And one important security consideration here is that ADoX is effective against passive network monitors, so it does not protect against active attacks. But in general, the idea behind this document is to build foundation for first, to have the opportunistic security widely deployed so that it builds foundation for stronger forms of protection in future. Okay, so speaking of my measurements, I did two things. I was measuring the deployment of this standard at the name server level and at the resolver level. So for name servers, I'm presenting here the results from March 2026. And what I did is that I measured the deployment among all the root letters, all the TLDs, and over 300 million registered domain names. So how I did it, first I would start with a bunch of UDP scans. So I would get the NS records for all the domains and then find IPv4 and IPv6 addresses of those name servers. Then to each name server IP, I would send one DOQ and one DOT query just to check whether those encryption transports are supported. And if they are supported, then I would resolve all the domain names that encrypted name server is authoritative for over the encrypted channel. So speaking of the adoption, at the root level, currently we have two operators doing some form of encryption. So we have broot that enabled ADoT a couple of years ago already, and they also gave a talk here at org like 4 years ago. For the hroot, it's more recent. It's been probably a month or two, and this operator deploys everything. So they do ADoT, ADoQ, IPv4, IPv6. So at the TLD level, we have 5 top-level domains doing some form of encryption. So the first one, .arpa, is a special case because it has no user-registered domains. But otherwise, we have 4 different country code ccTLDs. So once again, we have .kg, the ccTLD of Kyrgyzstan that supports everything, DOT, DOQ, v4, v6, and the remaining ones do ADoT over IPv4. So at the registered domain name level, the adoption is extremely low. So I identified roughly 3 million domain names and over like 2,500 name servers that would do some form of ADoX. So it's actually less than 1% in each category. But because we have that few name servers that are authoritative for millions of registered domain names, there are probably just a bunch of big operators that are behind those. So defining operator boundaries is hard. So one thing we can do is to aggregate by the organizations of name server IPs. So in this case, we see that 1.com hosting provider is behind the great majority of ADoX domains. So it's like 2 million out of 3. So the disadvantage of this aggregation approach is that we would also see Hetzner or OVH, which are not any hosting or DNS operators, but in fact, we just see somebody renting a VPS and running their own name server. So another thing we can do is to aggregate by name server domains. But the disadvantage of this approach is that we may end up fragmenting a single operator across multiple suffixes. So for example, we see that 1.com has substantially fewer domains than on the previous slide, and that's because this one operator also has name servers under hostnet.nl and antagonist.com. So similarly for VEDOS, for example, they use 3 different TLDs for name servers, which is why we end up by fragmenting the numbers. So here I'm plotting the number of ADoX domains per TLD. And while it looks very diverse, actually, in the great majority of cases, once again, we have 1.com who are responsible for the, who serves the great majority of those ADoX domains. So once again, we see the effects of a single provider. So speaking of popularity, some of the ADoT domains rank very highly in the Tranco list. So especially when it comes to different services of Meta, like we have Facebook.com, Instagram.com, and others. But on the contrary, ADoQ domains tend to be much less popular. So the most popular ADoQ domain appears at rank 147, and in general, ADoQ domains are much less popular. Okay, so the next thing I did was to evaluate the ADoX deployment among recursive resolvers. So the goal was to analyze both open resolvers and closed resolvers in IPv4 and in IPv6, but the methodology was the same for all, because I set up 2 domains only reachable over ADoT or ADoQ, and then I would request each tested resolver to resolve a unique subdomain of those. So the adoption rates are low, once again. So I did not identify any resolvers that would resolve my ADoQ domain. So in ADoT, I found slightly over 5,000 resolvers, open resolvers, that would resolve my domain name. But in fact, what's happening in the great majority of those cases is that the resolvers are forwarders. They forward the request to mostly Quad 9, and it's actually Quad 9 that is resolving the ADoT domain. And then I did not identify any closed resolver that would do ADoX. So my takeaway here is that the ADoX deployment exists. It's very low and very highly concentrated. We have one operator responsible for the great majority of ADoX domains, and very few recursive resolvers are capable of resolving those domains. So I run those scans once per month and publish the results on this website, so feel free to check. And with that, I'm happy to take questions.
Hi, this is Andre IC. I feel like that you speak about this is a thing that should happen as a good thing to happen. And I disagree. I think we need to measure what would be the impact on the global DNS system if we deployed recursive-to-authoritative, because I don't think this could work on the global scale at the moment. These numbers are interesting, but I would like to see a study on the impact if every resolver on the planet turned ADoX and every authoritative, what would happen? And the answer is we don't know, or everything would just go to hell and would stop working, because We can't do even TCP on this scale of level. That's why DNS uses UDP. So I'm not big fan of the encryption between resolver and authoritative. It has its place between, for transfers and privacy, but for resolvers, I'm not convinced about this, really.
So it's true that there is no performance studies that would actually show how bad it's going to be. So if such study exists, it would be great to.
Yeah, it would, but I think it would be bad, very bad.
Yeah.
Hi, Shane Kerr, IBM. So regarding published studies, we don't have any, but we have done some research on our own internally. And yeah, the performance is kind of catastrophic. TLS is just very expensive. I think, obviously we know you can run TLS at scale. I mean, the web is based on TLS, and 20 years ago it wasn't. So it is possible to transition from an unencrypted to an encrypted system, but there is a cost for sure. I know VeriSign has argued that it's not important, and I think for delegation mostly domains, that's true, because if people are using QName minimization, in spite of a presentation earlier which showed that maybe it isn't that important, but if you have QName minimization enabled, then there aren't as many privacy concerns. But we are not a delegation. Most of our customers are actually providing real information about their services. And there's a lot of information about your infrastructure, about where things are located, about what your customers are doing that comes straight to us. And if anyone was to get access to that data, I think we have to be humble and realize that there are real possible security problems and attack vectors that exist there. So I think I agree with the implication that it is good to try to move forward with encrypted resolver to authoritative sessions. That's it.
Hi, John Todd with Quad 9. To kind of counter the last couple of comments, I agree that, yes, turning everything on right now it would be catastrophic, and I think it would be very interesting to study that. But there's a staged process here. We're not talking about turning everything on overnight. We're talking about starting now, and what is it going to be looking like in a year from now, and 2 years from now, and 3 years from now. Right now, today, we have evidence of people tampering with, blocking, and intercepting queries between authoritative and recursive systems, right now. So we need to be prepared for this in another 3 years when it's become much more dramatic in the results. And so I'm very interested in the study. Thank you for doing it. I'd like to see what the results look like in 2 years from now, but I think people need to understand that it's an iterative process.
Hi, this is Andre again. So when we are talking about resolvers to authoritative, we are talking about good guys. But there are also implications if someone enables ADoX, whatever technology there is, there are also bad guys on the internet. And doing iterative deployment also means that it opens new attack vectors. And that's often overlooked in the development of the new protocols and also in the deployments. That when you enable something, you also open a new attack vector, exhaustion, like new ways how to DDoS the server because TLS is expensive, TCP is expensive. And this is very well understudied and needs to be studied first before we move forward.
Raffaele Sommese, University of Twente. I want to second John basically on there's a lot of governmental activities trying to block things at DNS level, and if this will help to some extent to solve the problem, if the adoption of encrypted recursive-to-authority will help people to deploy their own DNS server and have content-free filtering from the government, that would be great, I think. So I think this would be something good to have.
Yeah, we're not arguing that there are documented cases of interception between resolvers and authoritatives. It does exist.
Good. Thank you.
Thank you. Oh.
Is this going to be an iterative study? In other words, are you going to do this again next year and the year after? Or is that
I do it monthly.
Hmm?
I do it monthly.
Excellent. Thanks.
Okay, thank you. But now that we're out of time, so give a hand to Yevheniya.